You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, hello everybody. I am starting us off this week, and I'm going to take us way back to June 30th, 1908.
I love when you start them this way. Go for it.
All right.
Which, this was a bad day. This was a bad day.
It was already a bad time of, series of years. We're in the middle of the Great Depression? World War II? I know World War II.
1908.
1908. Never mind. I thought you said 38.
Nope.
I thought I heard 38 too.
Oh, well, I'm glad we clarified. 1908.
All right.
Let's just forget that part ever happened, and I'll cut that out.
Okay.
Sorry. I thought you said 38, and I'm like, that's
weird.
Time.
I totally heard 38 too.
Oh, okay.
I don't know.
Maybe you did. That's fascinating. All right, we'll find out.
June 30th, 1908 was a bad day to be in Evankivsky district in Siberia.
That was a lot of words.
Oh my gosh.
You know where I'm going with this,
I'm
Kirk.
So excited.
So around 7:15 in the morning, there was a man named S. Semenov. I don't know what S stands for, unfortunately. He was sitting outside his house in the village of Vanavara and facing north. And as he recounted the events 22 years later, this is what he saw. I quote, I suddenly saw that directly to the north, the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment, I became so hot that I couldn't bear it, as if my shirt were on fire. From the northern side where the fire was came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut closed and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that, such noise came as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, hot wind raced between the houses like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn a part of the iron lock snapped.
Amazing.
Yes.
I love this topic. Ugh.
Rachel looks completely shocked and bewildered.
Rachel has clearly not heard about this.
What?
Other witnesses described a blue light like a column moving downward across the sky, followed by a massive explosion and fire across the horizon. And for days afterward, the night skies across Eurasia were lit up with a strange glow at night, bright enough to take photographs by.
I did not know that.
Yeah.
Well, apparently the sky just opened up, and all of a sudden it's just the sun that's right there. What?
Well, this will be fun. So, Rachel, going by these descriptions,
what do you think happened?
What do you think happened? Because I know what happened. Victoria knows what happened. Some of our listeners know what happened. If someone told you about this, what do you think? The sky opened up and the sun came through, or what happened?
No. Okay, so my very first thought when you started describing it, I'm like, oh, it's the Northern Lights or something like that. But then you got further.
Terrifying Northern Lights.
Right. And then it continued, and you talked about the heat and the loud noises, and...
Very key.
Okay, so if there's loud noises and, thumping and things like that, and... is it, are they anywhere near a volcano, or,
That's a good guess. No.
Good guess,
or,
no.
Could it be, I have no idea.
You're going in the wrong direction. That's all a clue.
Okay.
Take them at their word for what they saw and where it came from.
Is it a meteor?
Hey.
Ding, 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 ding.
Oh,
All right.
Okay, like a really big flaming meteor. How close
Let me
was it
continue
to
my
this
story.
town? Okay.
So Vanavara, which is this village where Semenov lived, is 40 miles south of the epicenter of what is now known as the Tunguska Event. And this was named after the Podkamanaya Tunguska River, which was near where it occurred. So seismic monitors also recorded this event as about the equivalent of a 5.0 earthquake, but it was not an earthquake.
Fair.
So pretty soon after the event, it was suspected that it was caused by a meteorite impact. So, Rachel, yes, you were right.
Okay.
However, investigation of the actual site was quite delayed. As you may have learned in history class, the 1910s were a pretty unsettled time in Russia.
Really?
There was World
really?
War I. There
stuff
was
going on.
a little revolution
I-
in 1918.
1917.
1917, sorry, yep. What with one thing and another, it was 1921 before any kind of expedition was launched to the area, led by a mineralogist named Leonid Kulik. And
That's not ideal.
in 1921, he wasn't even able to visit the epicenter site, but what he did see, the limited amount, supported the meteorite hypothesis. He was finally able to get funding for a real investigation trip in 1927.
All right.
Unbelievable.
Really,
That's
yeah.
distant.
There was still plenty to see, though, from what I gather, right?
Yes. What he discovered was not what anybody was expecting, because if there were such a large meteorite impact, you would expect a big honkin' crater. They did not find any crater.
What?
Yeah. So as they approach the site, the trees are all laid down flat, pointing away from the blast. But when they got
Like for miles
for
and
miles
and
around,
miles. Yeah.
yeah. So a total area of 2,150 square kilometers or 830 square miles had been leveled.
I'm sorry, how many square miles?
830 square miles.
830.
Yeah.
It was big.
It was big.
My jaw is on the floor. None of you, obviously, on an audio format, can see my face, but my jaw has just been on the floor this whole time. What?
Yeah. But when Kulik and his team reached the epicenter, they discovered an area about 8 kilometers across of scorched and blackened trees that were still standing upright.
What?
And then just surrounded by this concentric area of downed trees.
What?
Yeah. So since 1927, there have been hundreds of subsequent expeditions to collect physical, radiological, biological, mineralogical, and various other types of data.
Yeah. Where's the meteorite?
Well, so the best supported hypothesis is that a giant meteor of about 50 to 60 meters across, or possibly a comet, entered the atmosphere and exploded about 5 to 10 kilometers above the Earth's surface.
Yeah, airburst.
An airburst, exactly. So because the blast in the center is straight down, it didn't knock the trees down, it just burnt them. And then as you got further away from the center, the force became more lateral.
Right.
So this blast, there's various estimates depending on who's making the guess, but this blast was equivalent to several hundred to several thousand times the force of the Hiroshima bomb. Yeah. And going back to that part that you had not heard about, Kirk, with the weirdly glowing skies at night, they think that the most likely explanation is that this was light reflecting off of high altitude ice particles that had been formed as a result of the meteorite passing through the atmosphere. Meteor.
Interesting. I wonder. You didn't happen to see if the clouds, if the light was seen all night or just like part of the night?
I did not read about that.
I'd be curious, because there's a phenomenon called noctilucent clouds, which are night shining clouds, which are essentially ice particles and bits of dust and stuff that are extremely high altitude, which can create these amazing blue like clouds, but it's just after sunset, but they're not all night.
Okay.
Because you still have to have the sunlight hitting them. I was just curious if they saw them all night, or if it was just sort of like quote unquote at night they saw this light.
I don't know.
Because it has to be something to light it up if it's reflected.
Right.
So, very curious.
Well, this was in June.
The moon could do it too. So
Yeah, this was in June, so in like far north. So
okay, so the sun may have been always kind of present close to the horizon, even when it was under. Yeah, interesting. Okay.
but I think they've also observed similar phenomenon after the space shuttle. Maybe not quite as big. At any rate, so Siberia is known for being sparsely populated now, and it was even more sparsely populated back then. Mostly there were nomadic tribes and a few Russian settlers. So local reports indicate that 2 or 3 people may have been confirmed killed. It's hard to know if there might have been more. Say if there were like a nomadic family in the area and they were all wiped out, we'd never know.
Yeah.
But meteorites are in fact impacting the Earth all the time, or meteors, but most of them burn up in the atmosphere before they reach the surface.
Mm-hmm.
Yay.
Yay.
Yay, atmosphere,
Real
doing
good,
your
real good.
job. Yay.
The atmosphere is obviously more closely watched now than in 1908.
Right.
Yes.
So scientists believe that an impact the size of Tunguska happens about once every 300 years on average.
Okay.
And in fact, there was a similar but much smaller meteor explosion over a more populated part of Russia in 2013.
I remember
Shattered some
that.
windows, did some damage.
Yeah.
And even more recently, this October, there was a mysterious boom heard over New Hampshire. And they think that the most likely explanation is a relatively small meteorite explosion. But every 300 years, obviously it's not a regular schedule, but that's pretty frequently. And you can imagine the devastation if something like this happened over a heavily populated area.
Not
Yeah,
good.
not
good.
Not great. Not great.
Adding to the list of Victoria's topics of geophysical events that could kill you.
Could kill us.
Nightmare fuel, thanks.
Yeah, you're welcome.
Appreciate it. You have a theme here.
And most of them we won't see coming. Great.
That's right.
Appreciate that. Love it. Yay.
We'll let you think about that over our break. And when we come back, Kirk will have something entirely different for you.
Sure will.
Yay.
By now, you've all heard about the Society of Strange and know that we appreciate your support by joining the Society of Strange over at patreon.com/strangebynature. But I understand it. I get it. Not everybody has the financial wherewithal to support the show right now. If that's you, just know there are other ways you can help us out. We love it when you share us with a friend. If you can get out there and tell your friends about this great podcast you've been listening to. We love having our listenership grow. We just passed 5,000 downloads recently online, and that was a nice milestone. Looking forward to getting that up to 10,000 a few months from now. And you can help us get there by telling your friends about the show, or maybe just popping on to wherever you listen to podcasts and leaving us a 5-star review and telling other people, telling strangers why you love this show so they can make a good choice about coming here and joining our strange little family. So we appreciate you as an audience. We love everything you do. Sending us messages, becoming members of the Society of Strange, or just writing 5-stars reviews, or just telling your friends to come on and join the party. So we hope you do that, and we're going to get on with the show. So this story that I have is one that I came across actually just last week while I was doing some background reading on summit disease. So as things happen,
Right.
sometimes you happen upon something else. And I thought this was super cool. It's just like a little passing reference in something I read. Like maybe kind of go, wait, what? I want to know more about that. Mm-hmm. And so I thought it was cool, and I want to share it because it's a great example of just how strange nature can be in surprising ways that we don't really think about. So obviously from last week's topic, we know that fungus can infect insects. Right?
Yes.
Right.
And that's a great way to spread around. And obviously, part of why the fungus are inside the insect is it's a good place to grow and probably even get some of the nutrients and stuff that are necessary for for reproduction and whatnot to multiply. So some of you may also know that fungus can infect plants as well, obviously. I think we probably, at least I think about fungus infecting plants much more than I think about it infecting animals. It's kind of,
Yeah.
at least in my mind, much more common
Well, I
kind of
mean,
thing.
think about it. Like, technically, fungus like infects. I say with air quotes, like trees and stuff all the time.
Well, yeah, I mean, and I know why it's the word. I don't like the word infect either, because that has a very negative connotation. But that's kind of what I'm going to be getting at a little bit. So the great example I think you're probably thinking about is the mycorrhizal relationship. So if people don't know what that is, there are some special types of fungus that live in the soil, and what they do is they can actually sort of work their way, their little hyphae, like into the roots of plants, and they can take nutrients from the soil and give it to the plants, basically acting as a conduit for nutrients to get into the plants. We found a lot of this is kind of newer research that's been coming out showing that there's some plants that have no ability to get nutrients out of the soil whatsoever. Some can, some can't. So some plants are completely dependent upon fungus to be the ones to get the nutrients out of the soil and then get it into the roots of the plants. That in and of itself is so bizarre and strange and amazing. And it is kind of this whole mycorrhizal fungi area is kind of a new area of study, and we're learning more about it every year and finding out that it's like more and more and more common. It's not more and more common. We are discovering more and more examples of how common it is.
Right.
And so there's two scientific papers I read this past week that had a reference to something that just blew my mind that ties in with all this. And I'm going to tell you what they're called. One is called Fungi that Infects Insects Altering Host Behavior and Beyond. Interesting title. The other one was called Carbon Translocation from a Plant to an Insect Pathogenic Endophytic Fungus. Just sounds like some great bedtime reading, right?
Right.
So I want to give you the gist of what these articles mention because it kind of blew my mind. So one of the things we know about these mycorrhizal fungi is that they can transfer, say, nitrogen from soil and put it into plants. And that's going to benefit the plants. And studies have shown that they actually get something in return from the plants. So this is a two-way relationship here. And nitrogen is one of the things that plants have to grow. It's really critical to growth. And it's in our atmosphere, but plants aren't good at getting it out of the atmosphere. Bacteria in the soil are really good at what's called fixing nitrogen. They can like bring nitrogen and store it in the soil. And then the plants can then get it out of the soil. So plants can get that. And plants are really good at getting carbon dioxide or carbon out of the air and putting it into the plants.
Right.
But fungi who are living, just like some of the plants have trouble getting the actual nitrogen out of the soil, the fungi also need carbon, and they have trouble getting the carbon. So that's something they can trade. So the plants have actually been shown to take carbon, which they have a surplus of, in many different forms. It's not just like, here's a carbon atom. It's in more
Right.
complex
It's in,
forms.
like,
I'm
sugar
I'm
and-
simplifying a lot here. But basically, when this fungus is getting the nitrogen and giving it to the plant is giving carbon back to the fungus. So everyone gets what they want, and it's a win-win.
Right. Symbiotic
So that-
relationship.
Yeah, so that's pretty cool. And that's been shown in like countless studies. This is like a well-documented thing now. However, this research, specifically the paper Carbon Translocation from Plant to an Insect Pathogenic Endophytic Fungus, has shown something I think is way more bizarre. So hang with me here.
Okay.
The scientists were specifically studying a fungus called Metarhizium robertsi, and this is a mycorrhizal fungus that will infect the root systems of trees. However, this same fungus will also infect insects, just like kind of like we talked about last week with the ones that infect insects for summit disease, right?
Right.
This doesn't cause summit disease, but it will take over and reproduce inside insects and plants. That alone is kind of cool.
Oh, okay.
But what the scientists in the study were able to prove is that when this particular fungus infects insects that are living in soil, it will kill them. And it can then take nitrogen from within the insect's body and transfer that into the plants which it has simultaneously infected. So basically, the fungus is farming insects for nitrogen
Right.
to feed to the plants so it can get carbon in return.
Sort of like your house cat killing a mouse and bringing it to you. Except you don't want a mouse, and the plants do want the nitrogen.
But you don't. You don't really want the mouse exactly.
I had dogs that did that.
It is. I think it blew my mind that you know
that's crazy.
the fungus is harvesting nitrogen from insects to feed it to trees. Like that's just.
That is pretty crazy.
It's so weird. You look out at trees. I think we used to think of as like trees. Oh, they're doing it all by themselves. You know, they're just pulling nitrogen out of the ground, pulling water out of the ground, combining it with carbon dioxide, making their own food. They're self-dependent. And then we find out, oh no, they're actually dependent on this fungus to get the nitrogen out of the ground. And now we're like, oh wait. In some cases, actually the fungus is infecting insects to get the nitrogen to give to the plants, so they can get the carbon that the plants are taking out of the atmosphere. Like. When you start studying nature, you find out that everything is so much more complicated and so much more interconnected than we presumed in the past. So I thought it was so cool. I wanted to give you a quick little skinny on how they figured this out. They basically used radioactive carbon-13 and grew plants in a sealed chamber, and so they could show that that carbon-13, which they could trace, and which was in the air, ended up in the plants. They could show that.
Right.
They eventually showed that same carbon-13 ended up in the fungus.
Right.
That definitely shows that they were getting something in return. But how do you show, like, in this experimental setup that, like, there's actually, it's coming from the insects into the plants? They actually had two different setups. One where you had like a control setup where there were no insects in the soil, and another one where you had insects in the soil, but there was a 30 nanometer mesh between the layer where the insects were and the roots of the plant were, so the insects could not actually get to the plant roots.
Okay.
And the insects were the source of the nitrogen that was in this soil. And so basically the only way the nitrogen could have gotten from where the insects were to where the plants were is if the fungus, which was known to infect both, was actually growing its hyphae like through that mesh into the roots of the plant. And when they looked at it and measured the biomass of the plants that had the insects in the soil just down below there, they had much greater root mass, which you would expect to see if they had access to greater levels of nitrogen.
Right.
That's so cool.
So
That's
really
amazing.
cool and just bizarre, and
Man, nature's so cool.
I don't know. I saw it and I'm like, nature's cool.
It's
so neat.
just like
And
all of
thank you,
these
scientists,
relationships.
for like studying all this stuff and
Right?
figuring out all these cool things that I can go, wow.
and then
about.
figuring out how to show that this is what's happening.
Yeah, that's one of my favorite things about reading some of these research papers and stuff is figuring out the methodology that someone came up with to try to prove something. And then other scientists come along and go, oh, but did you consider that this might have happened? And you're like, oh, okay.
Yeah.
How can we design it better to rule that out, and keep on refining and doing it again and again
And the other
to
thing,
make sure that your
the
results
thing
are
is,
correct.
They're not trying to prove anything. They're trying to disprove their hypothesis.
Yeah, exactly.
Well, it's
Yeah.
a very common misconception with a lot of non-scientific literate people. I don't know. I see it a lot of like people
That you're
not
trying to
knowing.
prove versus disprove.
Right.
I mean,
prove your point.
Yes and no. A lot of scientists really are, you have your hypothesis and
You want it to be right, you really
Yeah.
do, but you're trying to
you
shut
are
it down.
trying to think of all the possible ways that you could be wrong. But really often it's the people who are replicating your research who are trying the hardest to prove you wrong.
Yeah.
That's fair.
You know what I mean? It's like,
Yeah.
yeah,
Like, I'm going to take you down.
exactly.
Oh.
So that's all I have. I just wanted to share this just completely bizarre relationship that I came upon when I was studying about insects and fungus. So
That's
Super
crazy.
cool. Thank you.
Thanks,
you're
Kirk.
welcome.
Oh.
So we're gonna take a break, and when we come back, Rachel, you're gonna finish us off with one more cool story, right?
Yes. Alrighty, everyone. This actually came as a request by a listener and a friend of mine. So, Lauren, this is for you. I'm sure both of you have seen on leaves, especially in like early summer, late spring, that sometimes leaves on some plants have like this foamy substance on them.
Sure.
Mm-hmm.
Well, either of you know what that is caused by?
Spittle bugs.
Yeah. We're talking about-
That'd be my guess.
We're talking about spittle bugs today.
Oh, awesome!
Yeah,
I was
those
hoping
are cool.
we talked about this
They're
someday.
so cool. So they're actually also called frog hoppers. They're part of a super family, Cerocopodia. Yes, Cerocopodia. And it is part of the true bug order group of insects. So, like, it's in the same family as
Box elder bugs.
aphids, cicadas, bed bugs, shield bugs, all of those fun little dudes.
Yep.
Generally speaking, they look really cool when they're adults, and we will talk about them as an adult as well. But they're most known for their nymph stage. So they go through partial metamorphosis. They start out as an egg, and then they turn into a nymph. And what happens there is the nymphs are taking plant sap from inside of leaves and stems from whatever plant that they are predating upon. And, well, we call them spittle bugs because it looks a lot like spit, right? Like
Yes.
if we
Yeah.
spit
Sure does.
on the
Bubbly
ground,
spit.
right? Well, so it's not spit.
Okay.
They drink in the sap, and when they are, so they feed on the sap and they're trying to utilize as much as they can, but to get rid of a large amount of water when they're digesting and trying to get all of the nutrients from the sap itself, there's a lot of water in that sap, so they have to get rid of it somehow. So
How do
they
do
have
that, Rachel?
So what they do is they create that foam using special breathing tubes to create little air bubbles with the water as they secrete it out of their butts.
So
Lovely.
it's bug pee.
Yeah.
Yeah. I mean, that's
Bubbly bug
Exactly.
pee.
One of the articles I was reading about this suggested they should really be called piddle bugs, not spittle bugs.
Piddle bugs.
okay. All right. That works.
I mean, it's fair. So what they're doing is they secrete that they secrete all of the liquid and they create this foam. And this foam is actually acting as sort of a protector for
Right.
the nymphs themselves. They have a special breathing tube that allows them to be able to stay within this relatively protective environment. Like, I mean, it's a bunch of bubbles, but it wouldn't. I don't know. Most animals are not going to go, "Ooh, that looks super tasty. Let's go eat those bubbles." You know?
Right.
It doesn't look like any other kind of food.
Right. It doesn't look like anything. It just looks like something weird is happening there. So normally an animal wouldn't be able to survive on a diet that's so low in nutrients, but the insects, so the frog hoppers digestive system has two symbiotic bacteria that provides them with some essential amino acids so they're able to so they're able to survive. The foam itself serves a number of purposes. It's not just protecting them from the view of predators and parasites that might want to eat them or use them, but it also keeps the nymph protected against heat or cold. So it's a nice thermal control for them, and it's also a moisture control. Because the spittle bugs, when they are, when they're in their nymph form, they don't have really a strong exoskeleton like a lot of other ones. So this actually helps keep them nice and
Moist.
moist. I was trying to avoid it. Moist.
Go ahead. Let's all just say it together.
Moist. Because otherwise,
Some people just quit the show for good.
yeah, they did. Without the foam, the insect actually would very much dry up, which is crazy. So what happens is the nymphs will pierce the plants and they'll suck up the sap, and they cause very little damage to the plants other than, drinking some sap. And then they just create this foam that apparently tastes awful. I have not tasted this foam.
Well, I mean,
I do not
it would.
plan on tasting this foam. And of course, it's pee, pretty much.
Bug pee.
Yep. Great moisturizer, apparently, according to Rachel, though.
Apparently, yes. So once they eventually go through and finish their metamorphosis, or actually go through the incomplete metamorphosis, and turn into an adult, adult frog hoppers actually will jump from plant to plant. Some can jump up to 70 centimeters vertically.
Oh, wow. Okay.
Rachel,
Pretty
this
good.
has a strange connection to my topic for next week. I'll just leave it there.
I
Oh.
am intrigued.
Suspense.
Oh man, listeners, you don't know this, but I also have to wait now, and I don't like it. So it's technically a more impressive performance, like jumping that high, relative to body weight than fleas. Fleas are known for being able to jump very, very high. Frog hoppers, it's more impressive, which, I mean, fair. They can also...
But you don't see them in circuses, so...
No,
what are
you
gonna do?
don't.
Wow.
Darn. Spittle bugs can jump 100 times their own length, technically.
That
Which
seems
is
like
amazing.
a lot.
That is a lot. I mean, okay, they're not... Depending on the species, they're not huge. They're not going to be like a giant, like a grasshopper or anything like that. They're generally about like an inch or two.
Here's
So
my
it's
very
a-
important
super.
question, though.
Yes.
So if humans were able to do this, how many Rachels would
Ooh.
they be able
That's
to
didn't
jump?
do
exactly
that
what I was
math.
about to ask. Is
Great
Oh,
minds think
man.
alike, Kirk.
it'd be 100 Rachels.
Yeah,
It
which
would-
is
I mean, technically, if we were spittle bugs, it would be 100 Rachels. I would be able to
Which
jump
is
100 Rachels.
yeah. I need you to do the math right here.
Add two
right now.
zeros.
Do the math. Yeah.
Well, that's the problem with imperial units. It's not so easy.
Yeah, yeah.
Not so easy to do that. Oh no.
If you knew how many inches tall you are, you'd be set.
Uh,
You're what? You're 6'4"?
64.
Okay.
Yeah.
So 6,400 inches?
Yeah.
Wait, did you say Rachel is
6,400.
6'4"?
No, 64 inches.
She's 6'4",
I'm pretty sure
and I'm like,
she
man,
did say 64.
We've been saying she's short, and I thought
six-
she was shorter than me. I must be way
five.
taller
She was
than I
doing
thought.
the
5 times
math.
12 is 60 plus 4 is 64 inches.
There you go.
I think we both heard that, but I knew she was doing it she was talking about inches, not that I'm 6'4". That would be my cousin. Many of my cousins, actually. I don't understand why I'm only 5'4". They must have stolen the height from me. Anyway.
So 6,400 inches, so we're looking at 533 feet.
I like that. I could make it across the parking lot.
Winter would be handy.
It
Yeah.
would be great.
Jump over the snow.
Just
You'd probably
done.
injure yourself on the landing, but
I would fall all of the time, Kirk. I do not have graceful landing.
how is that any
Ever.
different than normal, though?
Exactly.
Okay, moving on.
Moving on. So a lot of frog hopper species, when they're adults, actually resemble leaf hoppers.
Okay, I was wondering.
Yeah, so they're in the same family or same order of insects. So leaf hoppers are these little tiny bugs. They kind of, oh man, how do I describe them? They're small enough that you can't.
Didn't you say earlier that they're related to like shield bugs and things?
Yeah,
Well, they're all in
That would
order
be-
Hemiptera.
yeah.
So,
Okay.
Leaf hoppers are in that group as well.
but so leaf hoppers, they have kind of a pyramid type shape. Their wings
Yeah.
at rest over their back kind of form a tent. And they're,
Yes. Usually bright green.
yeah, flattened laterally.
Mm-hmm.
Ask me how I
You
know.
can't really distinguish the separate parts of their body at that point, mostly because you see them when their wings are laying down.
See, I get confused because I'm old school, so I put leaf
Things have
hoppers
changed,
into
Kurt.
Homoptera, not into Hemiptera, so
Things have
I'm
changed,
just
Kirk.
old school like that. That's why I was confused.
So
Little taxonomy debate. Save it
you
for another time.
you can you can distinguish the difference between leaf hoppers and frog hoppers because frog hoppers will have a few stout spines on the hind leg,
Okay.
whereas leaf hoppers only have like a series of very small spines. It seems very minute difference here.
Well, I'm looking up some pictures, and if I saw one of these, I'd be like, ooh, it's a leaf hopper.
Mm-hmm.
Yeah, I think for
Interesting.
most people, they're
people-
probably basically the same.
More or less, they're gonna look the same. One other fun thing before we go, the oldest frog hoppers are known from the early Jurassic period. So they've been around for a few million years.
Mm-hmm.
I just found that out, and I thought that was just crazy. I understand that insects have been around before the dinosaurs, but I heard about just leaf hoppers, these little tiny insects being around from like the early Jurassic. That just kind of blows my mind, at least personally speaking.
Well, when I looked up frog hoppers on Google image search, one of the images that came up was a frog hopper in amber.
Yeah.
Well, there you go.
So there you
There
go.
you go. Yeah. So I just really wanted to talk about these cool little insects that just, when they're nymphs, just have a bunch of foam as a protector, and they look weird, and it's bizarre. And I wanted to chat with you all about it today.
Whenever you call it foam, I'm picturing one of those foam parties.
I've been to those, and it looks exactly like that.
I don't even know what you're talking about, and that's okay.
Well, Victoria, go ahead and do some Googling tonight.
I'm a little afraid to
foam
do that
parties
now.
and- yep.
Okay, I
It
say
is
foam
a
party.
it is a like a nightclub thing where they
Yeah.
flood the entire dance floor with thick foam.
Okay, got it.
I will say my shoes were never cleaner.
I think the last time I went to a
Okay.
nightclub was probably 20 years ago. So there you
Fair.
go. I'm not cool.
Fair enough. You're so
Well, you're cool to
Victoria.
us, Victoria.
Thanks, man.
You just got to go ahead and shrink yourself down, and you can go to the Frog Hopper. Well,
Nightclub.
that's P. Don't do that.
Yeah, no,
All right.
don't do that.
We're gonna end there.
And on that note, we're going to wrap up the episode.
Yep. Thank you all for joining us this week.
Oh,
We'll see you
my.
next week, everyone.
Bye, guys.
Bye. Anything anyone wants to add to that?
I feel like that was more than enough.
Haven't we said enough?
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.